Hello and welcome to the Boat Shed. In today's video, we make some more progress on the cockpit sole, or floor if you prefer, and we answer that age-old question: can you 3D print highly accurate vacuum-powered drill jigs for mounting hardware? And well, this little guy right here might have something to say about that, so stick around. In case you're new here, my name is John and this boat is Antidote. Now, I am not a pro boat builder, I'm an engineer and a sailor with the dream of fixing up this old boat to go sail around the world someday, but we got a lot of work to do first. Last time you were here, we put these Coosa pucks in all around the perimeter of this cockpit sole, and now we want to infill the center section. There's a couple things here. There's a bit of a high spot around the edges, and that's just because I think on the original build, they just laid the glass into it. So we want to buzz that down so it's flush, and then I'll probably wrap the glass around so this is fully sealed in. Some people have asked, why even bother with this and not just throw it away, start again? Certainly could have done that. You know, the first thing I would have probably done is rebuild this piece, so I kind of figured I already had a starting point. And so in my mind, it was fine, but yeah, you could certainly have just started over again if that's what you want to do. I'm happy to try and keep some things out of the landfill if I can, so on we go. Since I'm using a 5:1 epoxy here and I didn't use any peel ply on this glue up, I do have to consider that there's some blush that's formed, and instead of just trying to sand that off, I really do want to clean that first. So I've used a Scotch-Brite pad and some soapy water and just cleaned this off. It only takes a few minutes. It's not really a big deal. It is a small pain, but not too bad. So this is all ready to roll now, and the blocks have come out pretty good. They're all pretty much level. So now when we buzz this edge down, we'll just try to flatten those out, do the best we can, and then we'll glue the center part in. Let's get going. Well, after knocking down the perimeter around this whole piece, that fiberglass lip, which I only have this one short clip for, unfortunately, I forgot to hit the record button again. So whoever said making YouTube videos is easy, well, they were totally wrong. So this looks pretty good now. I did notice there was some waviness after that initial sanding, so I went back out with the level and some tools. I even used the planer a little bit to just get this nice and flat. Now, before we go ahead and glue all that center core material down, I plan to use vacuum to seal it all up. So I want this all to get sucked down nice and tight to this flat table. And that's how I'll get this floor to be nice and flat. Now, it might be difficult to see on the camera, but the permateak actually sits a little bit low in this pocket. And that's because the original teak was thicker material, and so we're a little bit low now. We don't want to have a puddle in here when it rains or when we get water in the boat, so we want to raise this a little bit. And so to do that, I've picked up some foam from our friends over at Divinicel, and this is the H130. So this, I can stand on this without putting, any marks in it. It's very dense foam, even though it is flexible because it's only 1/8 of an inch thick. But this brings us pretty much flush. So I think I'll put this down, one layer of glass to seal it all in, and then we'll put the permateak panel on top. So my hope is that by putting these materials on the underside, when this gets flipped over, that it'll prevent the bottom from crowning as it gets pushed down into the table. So this will help it maintain the right shape. So for now, it's just going to be in there as a template, and later on we'll glue this in. Let's take a second to thank some of the new Patreon and YouTube members that help keep this channel floating along. Now, if you're interested in some extra updates and ad-free videos, you can check out the Patreon link below or hit that join button. Now, the folks whose names are appearing on the screen go the extra mile to keep this channel working, and I couldn't do it without you. Thank you all so much. Now, back to the video. Now I want to start putting foam in the center core section of this cockpit sole. And I've decided I want to go with a thicker product because I want to get really good stiffness and strength on this panel, partly because the pedestal is mounted here, so there's a lot of pushing and pulling and forces that can be applied to that. So I want this whole thing to be really stout. Now we're using the 1-inch Coosa. You can see it's got the fiberglass in it there, so it's a really great panel, and of course totally waterproof. That's the main thing that we like about it. Now I debated on doing this out of one piece of foam, and it certainly would have been easier to cut out, but I think making many small blocks gives us a better chance in this application of getting less voids and also adhering to the shape properly. All of these were cut out on the table saw, which was a lot of fun and a huge mess. Now if I would have used Divinycell, I could have made the panel out of one piece and then just cut it using an X-Acto knife, because there's no fiberglass reinforcement in that. But this is a stronger product in many ways, and so we're going to go with it, and it was a lot of extra work. So what we're going to do now is cut out this on a template to get the right shape. We're going to set an 1 3/4 or 2-inch reveal or cutback, because this has to seal against the lip on the upper cockpit. And once we get them all fit in here, then we will buzz them down, get them ready to glue in. We used the jigsaw here to finish up the cuts, and then after trimming out the panel mosaic, I had the shape that I wanted. I transferred the blocks to the other table and started cutting the relief in the bottom of these blocks to allow them to sit flat inside of this new part. After letting the vacuum run overnight, this is ready to open up now. Let's take a look inside. You can definitely see here where all the edges of the blocks are. That's where all the spare resin came up. So hopefully there's not too many voids in there. We'll find out. This is the part where I've gotten into trouble the last couple of times forgetting to pull the peel ply off. Now I've got a camera rolling there, another one down there, so hopefully we've got it this time. Let's see how it looks. Well, I'm pretty pleased with how it's worked out so far. No voids. It looks like it's sealed up all around all the perimeters. Good amount of squish out, but not too much. I didn't waste too much epoxy, so I think this worked really well. It's definitely gaining some weight. We'll see how we end up, but I think we're gonna now take this down, buzz down, even this out a little bit so we can lay some glass over top, round over some of these edges. It's coming along. Well, the goal of the sanding there was really just to break down the high spots. This is a little bit wavy, but not too bad. So I think what I want to do now is cut out some glass to lay over top of this. And we're going to do 3 layers total. We'll do a 1708 and we'll do a 1808, which is running 090. So we'll put those 2 down first, and then we will clean everything up and do one that wraps around the edges. Here we go. The first 2 layers of glass went down really well here, and so well in fact that I decided to add the third, and I didn't wrap it like I had originally said. I just decided to also run it right to the edge, and so we've got a little bit of a stack going here. And instead of trying to wrap the glass, the thick glass around the edge, knowing that that would be quite difficult, I'll just try and use a little tape. So I have a 4 ounce, maybe it's a 6 ounce cloth tape that I can run around the edges to seal things up. Now, one of the experts that I rely on said it's probably not necessary, but it wouldn't be a bad idea. And the other one that I talked to said, yeah, I probably would do that. So we're going to err on the side of caution and go for that. So we'll trim this all up, sand it down, put a little bit of a profile on it, round over the edge, and then we'll be ready to glass that on. That edge looks pretty good. I think that's going to work really well to take that fiberglass tape as the last step in sealing up that side of the part. But before we go ahead and do that, we'll save that to the end of the day because it's going to make things all sticky on this part. So let's move on and start cutting some holes here for the binnacle to mount that back on the middle of this piece. So we have the main hole here and then the 4 outer bolt holes. And something that I'm concerned about is getting those holes exactly plumb and straight, so that when I go to mount the binnacle, everything slides through nicely, and then the back plate that holds the cables will also go back on and everything will line up. So I do want to make some sort of jig for this, and I thought let's have some more fun with the 3D printer. So we've got this guy that we cooked up, and this is a main hole and then the 4 locating holes. Now these do look a little large, and that's because I've made up these little plugs that can go in there, and there's different sizes. So I've got one there for like a 1/4 inch pilot hole. Then we have the 1/2 inch main bolt hole. And I also made some 3/4 inch ones in case I want to over drill them to put epoxy plugs in there, or maybe even some fiberglass tube in there. So the idea is that this will sit on here and allow me to get the holes lined up and drill them all through. The center part also accepts the hole saw, so that just goes in nicely and we'll guide that. So hopefully everything will work out really nice when we do it this way. Now how are we going to hold this down? I thought we would have a little fun and try to use vacuum. So I've got a little nub here that'll accept a hose, and then that actually tunnels through the part and comes out right there. And then I've put some neoprene 1/16 of an inch thick tape on this, hoping that I can seal that up, evacuate the air, and suck this part down onto the panel to hold it still so that I can do my drillings straight through. I also put some notches in the part on each end so that I'd be able to draw a center line, which we shot out on a laser, and then we can line this up to try to make sure that we've got this dead in the center of the piece. Now, doing this, I've learned that the original mount was not actually properly centered, and that's probably not a huge deal, so I'm probably overthinking this, and that is a theme of the channel, but we're having fun, and we'll just re-drill these holes. They're going to be a little off where they were originally, but it's going to be more centered and also clocked, more dead zero straight ahead. Is it going to work? I don't know. Let's find out. Well, I've got it where I want it, so let's fire this thing up and see if it works. That seems to be working really well. This is at 25 inches of mercury, and that's as low as this pump can go. I could bring my other pump in if I want more, but this feels really good. Like, I don't think I'm going to be able to move that, so let's go for it. We'll start by drilling the pilot hole first. Well, that worked better than I expected, to be really honest. The holding power with the vacuum was definitely enough. There's a little bit of flexing in the parts themselves. Maybe I could have used more material to beef it up a bit. There's sort of a balance between not wasting too much plastic and getting it to work. So we're kind of learning as we go here, but that was pretty cool. Now I had planned to go ahead and drill out one size further up to 3/4 of an inch, and that was going to allow me to put in some fiberglass tubes in here, or perhaps I want to overfill it with epoxy and then re-drill it. But I think before we do any over drilling, let's make sure the binnacle fits on here and that this works. So this is Antidote's pedestal, and we'll just put this on to make sure that we have a reality check here that these bolts work out. Okay, of course, one of them. These both look good, but they're a little sticky. But I bet they'll drive through. Let's see. Sure enough, they both drove through. Now they're on a 6-inch center, so I'll just verify that at the bottom they still are the same dimension. They're not on an angle or anything. All right, that looks pretty good. Nice and straight, and everything's gonna fit together nicely. So if you're as surprised as I am at how well that worked out, let's go ahead and hit that like button. It really does help the channel out a lot, and I appreciate it so much. Thanks. So now we're gonna take this back off, and we're gonna put the jig back on right where it was and over drill these to 3/4 of an inch to allow for some supports to be placed in there. Cool. This 3/4 inch drill bit is sharp, maybe too sharp. It's brand new and it's digging in and kind of cutting and getting stuck on the fiberglass. It's not actually sort of shaving it down like I wanted it to. But now I did want to clean up these holes anyhow, get a flat bottom in there instead of this point that we typically have on a drill bit. And so I was planning to use this 3/4 inch router bit to clean up the bottom. The trouble is, how do you get that spinning down there at the bottom of the hole? So I cooked up this part on the 3D printer, and this has a press fit, I'm thinking, hole to accept the shank of the router bit, the 1/4 inch shank. And I'm hoping that we can put this together and run this inside of the jig to clean up the bottom of the holes. As I'm pressing this in, it is really tight, so I'm thinking that we're gonna have to cut this part out when we wanna release it, which is too bad because it's a pretty cool tool, but let's see how it works. Our one-time use router bit holder did the trick there, and that was pretty neat. I'm really enjoying having the 3D printers here so I can make parts, jigs, and tools and stuff while I'm working on other projects. So this was made on PRUSA Core ONE and using their Prusament PLA. It's the cheap, not supposed to be a very strong plastic, but it actually did really well, and I'm not sure how many times it would take this job on, but it worked fine for what we were doing, so pretty cool. Now, I did start designing my parts using FreeCAD, which was a recommendation that someone gave me in the comments. And if you are designing parts or tools, things like that, it probably is going to work pretty well for you. So check it out, and thanks, whoever you are, for that tip. Planning ahead for the installation of the Permatique panel. And the folks at the company do not recommend mounting heavily loaded fittings through the Permatique, so cleats, winches, things like that. So the binnacle is going to kind of fall into that zone because there can be a lot of load on there. So what I want to do is use a hard surface directly below the binnacle, but slightly inside so you don't see it. So it looks like here we're going to want to go with about 9 3/4 inches. I don't know what that is in metric. And for that, I'm going to use 2 pieces of G10. I have a 1/4 inch sheet here and an 1/8 inch sheet. So we're going to buck these up on the saw just to get the rough dimensions that we want. And then I think we'll be able to use that vacuum jig to make a really accurate copy of the shape that we want and then transfer it onto here. So we'll have a nice inlaid G10 panel. Let's get going on that now. Once again, the vacuum jig delivers, and this G10 part is a really nice fit. Now you'll notice here that it is mounted slightly recessed under the pedestal base, and that's what I was aiming for. I want to have the Permatique come underneath, be a nice tight fit, and basically an invisible seam. We'll see if that works out. I started thinking afterwards that maybe I should have made the G10 larger all the way around, taken advantage of that, and put in another caulk seam for the Permatique. Now, I'm not so sure. Let me know what you think in the comments if you have a reason why you think I should have made the G10 base bigger, because it's not too late. We haven't glued it in yet, and the reason is we're still waiting for those fiberglass tubes to show up. Once they do, we'll glue all this together. We're gonna leave things here for today. Hope you've enjoyed the video. If you have, make sure you leave a comment and a like on this video. And if you would like to get caught up from the beginning, maybe you're new here, you can check out this playlist right here. And if you wanna get subscribed to the channel, we'd love that. Button's right there. See you next time. So let's get started on that now.